This first one was too fast. There's only 2 questions.
Yeah, I feel like these are going to go by fast.
That's what I'm hoping for. Okay, so part 2 on lesson 4 was the dice one. So an 8-sided dice has the possible outcome for each roll, 1, 2, 3, 4, 5, 6, 7, or 8. Calculate the probability of rolling a number greater than 5. And I got 3 out of 8.
Yep, same.
Me too.
5.
Perfect.
Yeah.
All right, who wants to do number 6?
I'll do it. Calculate the probability of not getting a number greater than 5. I got 5. Well, 5 out of 8. 5 8.
That's what I got.
Okay, awesome.
Perfect. Awesome. Yeah, that one was my favorite one.
Yeah, that was so
short.
Out of the set. Wait.
Although I will say lesson 5 was where I started to question whether or not I was staying in statistics.
Yeah, I did not like lesson 5 at all.
I didn't get lesson 5.
Yeah, luckily I found those video tutorials, because if I hadn't found those, I would have been like, no, I don't understand it.
Yeah, I needed those.
Okay, so sorry, this one I had to do extra paper because it didn't fit on the one. Okay, so for part 2, it has the mean and standard deviations. So number 6 is the mean of all quantitative scores in the GRE is 150.8 with a standard deviation of 8.8. So we had to find the mu, which was, I'm on the wrong, sorry. I just don't want to start reading my actions. Number 6, there we go. Mu, which is 150.8, and then the standard deviation, which was the 8.8. Is that what you guys got?
Yes.
Sorry,
are we part 2, 6A on lesson 5. Oh, wait, do we want to do the quiz on 4? Sorry, I jumped way ahead.
Oh
yeah. Probably a good idea.
Yeah, might as well go get the quiz over with.
Yeah, I was trying to find if we were doing the lesson 4, but okay, got it.
No, you're totally, yeah, so I skipped all the way over. Let me pull that quiz up real fast. And remember, we only one of us submit first, just so that way everyone doesn't have to redo it if we're wrong. Let's see here, quizzes. I like the new setup that they've changed it to. I think it's much more user-friendly.
Actually,
do you hate it?
I like it.
Oh, you like it? Yeah, so do I. I felt like the old way, I was like, why is this so complicated when it doesn't need to be?
Yeah, this is like a lot simpler and it just is cleaner, I feel like.
Yeah. So it's the lesson 4 group meeting quiz, right?
Yeah.
Yep.
Perfect.
I'm going to hit start.
Yes, okay, so make sure we give all the probability answers as decimals. Do not give them as percents. Is that an option?
Yeah. So human.
Answer the next 3 problems.
Oh, yeah, this demonstrates why my blood is so valuable.
That's a small graph.
Okay, so question 3, the blood types and the proportions given in the table above define a probability of distribution, true or false. So we know for it to be a probability distribution, the probability of an event X has to be between 0 and 1, which it is. The sum of the probabilities of all the possible outcomes of any experiments is 1. And if you add those together, it equals 1. 90. Well,
let me check.
Yeah, see, all of a sudden I'm like, does it?
Yeah.
Okay, perfect.
Yeah.
Okay, and then third, the probability that an event X will not occur is 1 minus the probability it will occur. And so it should, if it's a 1, if it equals 1, then it should be 1 minus 1 would work. So that should be true, I believe.
Yeah.
Okay. Who wants to take 4?
I can take it. Okay.
So what is the probability that a randomly selected person in the United States has type O blood? Around 2 decimal places. So we did, I'm trying to remember, I did this yesterday, but it would be 0.45. It wouldn't, I'm confused. Wouldn't it just be 0.45?
I believe so, because it's out of 100,
Yeah.
basically percent, so yeah.
Okay.
I know, I hate when the questions seem too easy where you're like, is it?
Yeah, it makes you second guess yourself. Oh, we have another person. Hello. Are you Haley?
Yes.
Hi.
Hi, Haley.
Hi, Haley.
Hey.
Welcome to our group.
How you guys doing?
Good. We're short our major Excel guy, so we're going to try to make it work today.
Did he drop the clock?
Yeah, he dropped it.
Okay.
Oh my goodness. Okay.
So we're just working on the chapter 4 quiz right now, or lesson 4 quiz.
Okay. Sounds good.
Okay, and Jason, were you doing question 5?
Yes.
Okay.
Question 5 is, what is the probability that a randomly selected person will not have type O blood? So 40, 55, so 0.55?
That's what I think.
Yeah.
Okay. So use the following information to answer the next 2 questions. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up on a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. If the dog guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Round to 3 decimal places. Okay, so.
Say how many dogs? Oh, I guess that doesn't matter.
Yeah, I think Tangle's the only dog. Yeah, because it says dogs were trained, but then Tangle's the one demonstrating.
So is it just 1 in 7 then?
6 samples from the patients who did not have bladder cancer. Oh, 7 bowls. Yeah, you're right.
Oh, yeah.
So I would think 1 in 7.
Yeah. Well,
so it's whatever 1 divided by 7 is.
0.14.
You got 0.143?
Yeah.
yeah.
All right, Jason, it's your turn.
All right. And it came in a combined total of 54 trials. The dog correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer. There's little evidence that dogs can detect bladder cancer.
That's a tough one.
Oh, man.
I would say like somewhere in between, but I guess
that's what I was just thinking. I'm like, it didn't even hit halfway.
Yeah, it's not strong, but it's not little either.
Well, it says that it's very unlikely the dog would do this well. So.
By random chance.
Well, in part 1 of lesson 4, it says, what does it mean to be random? And so I just want to pull up, unless you guys wrote it down. Did any of you guys write down the definition of random?
I have it. I don't know where it is.
That's what I'm like. That's what I'm searching for. I'm like, where did I write that down?
Oh, it says any random process follows a distinct pattern over time.
A distinct pattern over time. So let's see, 54 trials, 22 times, but we don't know.
I want to say the second one just because I feel like if that it provides dogs can detect bladder cancer, I don't know, like, what are we going off of? We're going off of this information that we're going off of this these results.
Yes, it's the statement, it is very unlikely that the dog would do this well, that's throwing me off.
That's the thing.
Yeah, by random chance alone. So I'm guessing that it would be the first one.
Would it be the first one then? Okay.
I think, yeah, let's try the first one and see. That's.
Well, I have someone. I can submit it before to.
Okay. We'll see if it goes through there.
Yeah.
All right. Let's see here. So it's Kate's turn.
All right. M&M's are small chocolate candy. The M&M's website previously indicated that in the United States, the distribution of the colors in a bag of plain M&M's is given the following table. Got that there. Question 8 says, if you reach into a bag of plain M&M, or if you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy? Round your answer to the two decimal places. So what's the little green squiggle thing?
That's what I'm wondering, because this only adds up to 0.84.
So I wonder if the green one is the rest.
That is maybe a later. Oh yeah, the next question deals with the green, so I think we have to figure it out afterwards. So I think we assume that it rounds that this all goes to 1.
Yeah, okay. Because the green would be 0.16 if we
put that one in there.
So what it's asking about red. Okay, 0.13. Oh, it's yeah.
Yeah, 0.13.
So then question 9 is the probability the selected candy is green. So that would be the 0.16 because that's what we're missing.
Yeah.
So then it's asking what it's not green. What was the what percent is not green? So what was the
0.84.
Okay.
Yeah.
Okay, so the ACT scores of students admitted to a medium-sized public university in the western United States were taken from capix.com. The following summary statistics were calculated, and let's see, half of the observations are less than or equal to what number?
We're just the median, aren't we then?
The median?
Yeah.
Or the mean, sorry?
The mean, yeah. Well,
except for there is a mean right there. Oh, observations. Is that on there? No.
I think it would be the median, right? Because the median is the middle, so it would be less than or equal to that number.
That's true. So 24?
Yeah.
Yeah, I think so.
Top 25% of students scored above what number? So that would be in quartile 1, right?
Yeah.
Or yeah.
No.
3.
3 is higher than 1 is. Let's see.
Yeah, because 1 before the median, and then 3 is the 25, the part after.
Oh, right. That's right. So would it be 27 then?
27.
Which of the following statements is not one of the rules of probability? The probability that an outcome will not occur is 1 minus the probability that it will occur. Probability is between 0 and 1. If the probability is high, then the probability is positive. Probability is low. It's definitely that one.
Yeah, that one. We all just read those.
Yeah.
Okay, Kate, do you want to submit, and then we'll see if we need to change any?
Do it right now. All right, we got it.
Perfect.
All right.
Wouldn't it be funny if one was like, I got a 0? I'm just kidding.
No.
Off of all of those.
That'd be horrible.
Okay, so now we get to go into lesson 5.
We press stop. We do stop the recording.
Oh, yeah. Yep, you're right. So I guess we can ask the team, do we need to stop every time we move on to a different lesson to submit the next ones?
You can. I've seen it done both ways.
Okay. So, because we didn't know if we needed to have her see each individual one, I guess, or if we can just put the same video in all 4.
You can do either or. I don't think it matters, just as long as, like, I've heard some people like say that their video gets cut off when they try, like, by like.
Try to go too long.
Yeah, if you try and go really long, like it gets cut off by like a half an hour.
Okay.
But I think as long as you like mention, like if you want to do it in one video, as long as you mention that you did lessons like 4, 5, and 6 today or whatever it was,
Okay.
then it should be okay. We should be able to give you full credit for it just because we can't see it on the video. And then we can talk about like maybe some insights you all had or like what one person said to help sway you with one answer or the other, and just we can work with you when it comes to that. Or if you want to do like multiple videos, because I believe that in the discussion board, it has, let's see, I'm going to the discussion board right now. I think it has one for each
lesson.
I think so, yeah. So I would do multiple videos personally.
Okay. So I'm going to stop this one and then I'll start the next one, you guys.
Okay, great.
Sounds good.